Hello, and welcome to this DevOps session, Canaries in the Code Mine. My name is Lucas, and I'm a Principal Solutions Architect at Amazon Web Services. Today, I want to talk about how you can improve your operational excellence by integrating your deployment pipelines with the AWS Observability offering. And when we talk about observability on AWS, we start at the foundation. Here, we can collect all the data that we need with Amazon CloudWatch and AWS X-Ray. That could be in the form of out-of-the-box or custom-defined metrics, application or infrastructure logs, or even telemetry information via traces. We can then act and respond on that information using Amazon CloudWatch alarms that we can set them up to, for example, make use of auto-scaling capabilities, notification of stakeholders, or even automated remediation of issues. We can then build upon the foundation to create fully managed and purpose-built services and features. For example, contributors' insights that allow you to understand all the services that are consuming your application and how they all affect the overall performance of the system. Containers and Lambda insights allow you to monitor and control your containerized application and microservices. Log insights provides you with a powerful querying mechanism that you can use against your data. Composite alarms, for example, allows you to logically combine together a bunch of different alarms. This is particularly useful in cases where applications have multiple alarms that can trigger for a particular event. Lastly, you can bring machine learning capabilities by using our anomaly detection service. This is pretty useful to further understand the behavior of your application. Finally, you can use CloudWatch Service Lens to have a unified view of all of the above. But today, the focus will be on this first service, Amazon CloudWatch Synthetics. So what is Amazon CloudWatch Synthetics? At its core, it's a website and API monitoring service. Unlike previously discussed services, Synthetics provide an outside-in monitoring capabilities. It effectively allows you to behave as if you're users of your application. The tests that you create can be set up as one-off executions, or you can run them in a continuous interval. Synthetics builds on top of the Puppeteer library and further enhances it to integrate with the AWS platform and services. Some of the examples that you can use Synthetics for are taking screenshots of web pages, generate PDF documents. You can automate form submission. You can, for example, also automate and crawl the websites. So why is Synthetics important? Well, one of the key things about Synthetics is that you can see your system and your applications in the same way that your users will see it. That really helps spot intermittent issues, but it can also help you understand when the issues were introduced. Following the AWS observability pillars, not only we can observe the state of your application, we can inspect it. It will really help you debug and discover potential issues. As well as inspecting it, we can also react or act on these particular events. So one of the things that we can do in the context of CI/CD and DevOps is integrating some of these tests into your deployment pipelines to understand whenever you're about to release a change or after you release a change, what sort of problems you might have introduced. And then you can potentially all of that lead up to a rollback of your pipeline. When we talk about CI/CD, DevOps and pipelines on AWS, we have to talk about the code services. In here, AWS has you covered from every step of the software release process. From the source, we have code commit, which is our managed Git service. We can then build our applications with code build, test them as well with code build, but also integrating with third-party services. And finally, we can deploy them using code deploy. All of this will be orchestrated with AWS Code Pipeline. And Code Pipeline will be one of the services that we'll be using today to show you how you can integrate your synthetic tests. Code Pipeline is a continuous delivery service for fast and reliable application updates. Allows you to integrate natively with the AWS set of services, but also third-party tooling. We're about to head on into our first demo today, and I just want to talk about a little bit of what we're going to see. I'm going to give you a quick overview of the system that we want to test, And then I will give you a quick brief on how to set up and get you started with synthetic tests and synthetic canary tests, but also how you can define a call pipeline that will allow you to integrate your application. So here we are on a sample website, and as you can see, it's relatively simple. It is a search engine for books. You can enter a search criteria. In this case, it could be an author name. You can click on the search button, and that will call an API that will return all the works done by that particular author. You can see some of the fields that are coming back are ISBN, publish year, language, name of the publisher, numbers edition, so on and so forth. We can go ahead and search for another one of my favorite authors, Neil Gaiman, and we'll see that we'll get his results back as well. We can see there are different search criteria such as author, title, ISBN, and publish year. On its own, it's a relatively simple site, but as you can see from a user perspective, there are already a number of areas that you need to consider. How is this going to look in different form factors? The text input then the user will be entering, buttons that will perform API actions, and all the different checkboxes that you have to click and make sure that they're going to the right places. So with that in mind, I wanted to start thinking about all the different tests that you will want to do in your synthetics canary checks. So we'll go ahead and jump into our synthetics checks in just a second. But also I want to show you what else our API does. So our website has a front-end side and an API. And the API, as it shows here, is just return the list of the authors for this published work for this particular author, and it's just a collection of JSON documents. We have another endpoint as well, which is fairly simple and just return a status 200 OK after some health check had passed. So we'll use that to make sure our site is healthy and not only up and running. So if it were to fail, we will return a different status code as well. Here we are on the synthetics homepage. So the first thing that we'll do is go ahead and create a sample canary test. We can see here that we have three options: using a blueprint, using an inline editor, or importing your script from S3. In this case, we'll look at the blueprints. That will give you a way to get started with your application and your testing. One of the examples that we had here is a heartbeat monitoring. So we can start already thinking about how we can plug this into our API endpoint that checks for the health of our site. We can also do API canary testing. We can do broken link checkers. So if you remember, we can crawl the DOM elements in our website and make sure for the presence or existence of elements. We can check for the correctness of their behavior, so on and so forth. In this case, we'll go ahead and select the heartbeat monitoring example. And as we scroll down, we see that we've been asked to create a name for our canary test. And we'll call that reinvent demo canary. We've been asked for a URL. Make sure that obviously, as always, you own the URL. You don't want to spam the site that you're testing. And this particular blueprint has the option of taking screenshots. And you can decide then when you're creating your own canary test what sort of things you want to be configurable. In this case, we don't really want to take pictures for a health check. And we can see here that our test code looks fairly similar to a Lambda function. So effectively, we're passing some application call, and the application will have an entry point. In this case, it is our handler call, which will run a function, and that function will ping our website, wait for a few seconds, and then return some status code. We can further enhance it with the environment variables, and then we can set a schedule in which we want to run this test. We can leave it as a one-off run, or we can have a continuous interval. You can also choose to run it after creation. You can also decide some of the data retention policies. As you can imagine, screenshots, log, and all those things, you have to consider how long you want to keep them for, where you want to store them, and then when it comes to access permissions, if you want the service to take control for it, or you want to create an existing one, or reuse something that you might already have. Then you have a bunch of optional settings that will leave that, and then we'll create our first canary test. Now we'll look into our pipeline. This is our code pipeline homepage. And we'll again create an empty project, and we'll give it a name for our pipeline. And just very similar to canary test, we can choose to create a role or use an existing one. For our source, because we're using code commit, we'll select that as our managed Git service. It will ask me to choose a repository name, and then it will ask me to choose a branch. Then I get to choose how do I want to trigger my pipeline. In this case, we don't really care about a build provider, but it will still warn us that nothing will happen. We'll select code deploy as our deployment mechanism, and we'll use Elastic Beanstalk to manage our application. Once we're done with that, we get to review the changes that we want to make, and if we're happy with that, we can go ahead and create the pipeline. So, I just wanted to recap a little bit what we just saw up on the screen. So I showed you three different things. The first one is a website that I built for this particular demo. If you remember, it's very simple. There's an input text, there's a search button, and we can search for authors, book names, book titles, ISBNs, years, and so on. On its own, it doesn't really do much, but we can identify already there are 3 or 4 features that as a user you really care about. We then went ahead and showed you how to create a canary test. For the particular example of the demo before, we picked one of the blueprint examples, but you can go ahead and create your own or import on existing ones. And finally, we created a pipeline. Because we don't need a build stage, it only has 2 stages. Our source, or where application code lives, and then a deployment stage, which we hand off to our Elastic Beanstalk service to manage our application. Because I want to run several tests against my application, I'm going to be using the AWS Step Function service. Step Function is a fully managed state machine service with resilient workflow automation and built-in error handling. It integrates with AWS services, but also has first-class support for your own services. Finally, every execution of our state machine is fully auditable, and it allows just for visual monitoring. So this is the proposed architecture that I'm going to do for this particular demo. As a whole, we'll have a deployment pipeline orchestrated by code pipeline. As we said before, our application code will live on code commit, and on every change to our repository, we'll trigger a new pipeline execution that will go from our different stages. It will get into code build, and code build will deploy our application using an Elastic Beanstalk. Once the application is deployed, we'll eventually trigger a state machine that will orchestrate all of our different canary tests. If we keep talking about solution, it's worth understanding that because of the powerful capabilities of step functions, I can create branching logics, retry logics, I can set up parallel workflows, I could even have nested state machines integrated. So you're only really limited by your imagination or your business problems. So in this case, on the right-hand side of the screen, you can see a sample screenshot of what a state machine might potentially look like. In this case, it's very simple. We're starting our application, we're running a canary test, and then we're rechecking whether we want to run it again or not. Really, the options are limitless. You could have one complex state machine per test with its own retry logic and error handling. You can have one big state machine that runs all of your tests in parallel, synchronously, through different nested state machines, so on and so forth. You can also, because of the error handling, raise various and different sets of alarms. So as well as notifying stakeholders for the application, you can potentially trigger rollbacks in your pipeline. So once a deployment is done and your tests haven't passed, you can effectively trigger a new pipeline rollback that will take you back to the previous version. We're just about ready to go into our second demo now. And in this particular demo, we're actually going to go into detail in the implementation of some of the stuff that we've just been discussing. We're going to show you all the different tests that I've created and how I integrated it into the state machine function. Then I'll show you from my state machine how I integrate those canary tests in there. And finally, I'm going to integrate that state machine that we created into our pipeline and execute it after a change to see how everything ties together. So here we are on our state machine definition, and we can see for the one that I created today, I really wanted to reuse it. So I put in some branching logic at the beginning to sort of say if it was running in a production environment or not. The way I decided that is that if it was running in a production environment, it will do a comprehensive set of tests, but if it wasn't, it would just run a simple test. For this particular example, we're going to be running our 3 canary tests, an API, a UI, and a status check, and we'll run them all in parallel. Once all of that is done, we'll get the results done and we'll continue with our pipeline. So it's worth noting that we haven't really executed the pipeline at this stage. This is just a definition. Here, we're picking up where we left off. As you can see, we already run our pipeline a few times and everything has been succeeding. We're still down to 2 stages, our source and deploy, and we'll go ahead and create a new one. Because I want to run my changes against the newly deployed application, I'm going to create a stage post-deployment. From that stage, I'll create a new action group. And as a provider for that action group, I'll invoke step functions. I'll be selecting the state machine that I've previously created. And because we had a little bit of branching logic at the beginning, I'm going to be passing some parameters in here to my state machine that identifies itself for this particular pipeline as a production environment pipeline. So we want to run the comprehensive suite of tests. As you can see, it's just a JSON payload object that has a key and a value. Once that's done, we can go ahead and save our stage and also save our pipeline. We got a warning here that we're making changes to our pipeline, and if we had an existing execution, it will get cancelled by hitting the save button. Now the pipeline has been created, and we can see source and deploy are still green stages, but our synthetic stage is in a gray state. That's because we haven't run it yet. So what we can go ahead and do now is just release our last change. We don't need to rebuild everything, we'll reuse the existing artifact. And again, we get the same warning that will cancel any existing execution if we run this. This will take a few minutes, and while that's happening, I'm going to go and show you the canary test that I've created. So now I'm here on my Canaries homepage, and as you can see, it aggregates all the canary tests that I've created for this particular demo. I can see all their executions, I can see how many have passed, how many have failed, I can see the times that they've been running. You can see that I've created 3. The names are fully descriptive. I created a heartbeat check that we can go and see now. We can see the last time it ran it passed. We can see it has 0 issues, we can see what the success rate of it is, and we can see it has a state of running. The reason being is that this particular check, it runs on a continuous interval as opposed to a one-off. So if you can see below down the canary runs, we can see that it's running on a set interval. There are no particular issues with the canary test, but we can go ahead and select one of the executions and see what information are we getting out of it. In this particular case, I don't really care about screenshots and haven't taken any, but we can check for the HRR file just to see the request, how it looks like. And we can see the endpoint that I'm hitting, as well as the return code that are coming back from my API. If you're familiar with HRI files, you can import those in various different tools to keep digging deep into the information that you see. If you want to access the raw logs, you can hit the Logs tab and you can see all the logging information that you had from that particular run. We'll go ahead and check our API Canary test. And we can see this one presents us with an alarm. That's because Canary tests can also be hooked up to CloudWatch alarms to react on particular metrics. We can see this particular Canary test is in a stop state. And that's because I don't want to spam my API, and so I run this whenever I need to. We still see that we're presented with the same view, and we'll have a look at the configuration of this particular test. We see that we define an alarm and that it's been triggering, and we'll see what the particular metric in this case was. If I wanted to, I could publish those alarms into SNS topics that I could hook into mobile notifications or email notifications. I can go ahead and review my application code, and if I wanted to, I can download the script, modify it, and re-upload it to change the test. If we pick our last execution for our API test, we can scroll down and again see that there are no screenshots, but we see there's a new tab here. This is our Traces tab. And that's because Canary tests can also be integrated with AWS X-Ray. And we can see for every execution of this test, all the different traces related to it. Just like you would expect from any service that integrates with X-rays, we can see the various different segments that our request went through in order to get the test working. One key thing about this is that whilst we can see things in the same way that user sees it, the Canary test would identify themselves as such, so that when you're looking at X-ray telemetry information, you can truly see what's been coming from a Canary test or what's been actually coming from a real user. Let's go ahead and check our last test. We can see that our homepage test also runs on an interval. We'll go ahead and select our last execution, and we'll see this one does take screenshots. So what I wanted to do here is just check for different form factors. So what I'm doing here is just checking how a desktop application or a desktop browser will look when rendering my website. The one thing that you can do with Canary tests that you're not limited to is that you can actually create multiple requests within one test. What that means is that within the same test, I can perform 2 requests against my site. And I can introduce myself as a desktop browser in the first one, and I say tablet browser on the second one. So within the same test, I can see that we'll see here that we have 2 requests. So now, if you wanted to test for various different form factors or functionality across devices, you can bundle all of those up together into one big test. So our pipeline should be done by now, so we'll go ahead and see how that went. So as we see, everything has passed. Now we see our synthetic stage has also passed. Let's go ahead and have a look at the execution of the state machine. We'll refresh and select our last execution. And we see it took the production flow. As you remember, we passed our variables and we said that this was a production build, and so we wanted to run the comprehensive suite of tests. After we passed the 3 tests and all the tests are done, we went ahead and finished our pipeline deployment. We're just about ready to wrap up our session, so I just wanted to recap a little bit our second demo. What I show you in the second demo is all the different tests that I came up with that I wanted to test my website off. One was a heartbeat test, in which all I was doing is just calling my status endpoint and making sure that I was getting an OK result back. I was doing an API test. I wanted to make sure not only that the SLA response times were up to standard, but also that I was returning the right data payloads back from it. And finally, I was doing a UI test or a homepage test. So on an interval, I was hitting my endpoint and I was rendering it with a desktop browser and rendering it with a tablet browser, making sure that my elements were responsive, making sure the presence of elements and making sure the correctness of the behavior of those elements. I also show you the state machine that I created. In my particular case, because I said before I wanted to reuse it, I created that initial branching logic. You don't need to do that. You can have different state machines from different environments. You could even have different state machines for different checks. It's really up to you what fits your particular use case. In my case, once it took the production branch, I was running in parallel all 3 tests, and I was only running them once. Again, another idea for you could be, for example, for the API test, you could run that 3, 4, 5 times and get a mean average response time. So you know that after a deployment, your performance hasn't decreased. Finally, I was doing some UI checks. And this is some of the hardest things to test. So it's really important when you're deploying websites, making sure that things are in the right place. Because ultimately, in a pipeline, we typically check for unit tests or integration tests and checks for correctness in call and functionality. But we left aside what your user sees. And it's really important that you make use of that capabilities in synthetic checks. And finally, we show you the pipeline and how to, with the pipeline, one way at least of integrating synthetic checks into it. In our case, we created a new stage, post-deployment, and we added a state machine in there, which will run a UI test. In your case, you could have that multiple deployment stage. You could have a stage in deployment stage where you run your synthetic checks after, and once all of that done, you might have a production deployment. Or you might have, what in my case is, correctness check at the beginning, deploying into production, and then running synthetic checks after. It's really what works for you that matters. I want to leave you with 2 related sessions to this one. These ones are very interesting because are coming from our Builders library track. That means that you hear it firsthand from our AWS engineers how we implement some of the things that we discussed today here at Amazon. So the first session is monitoring production systems or services. You'll see how we do it internally at Amazon and hear it from the people that implement it on a day-to-day basis. And the second session is automating continuous delivery. So very topical sessions what we discussed today, and I would highly recommend you to go and watch them. With that, I really want to thank you for tuning in today, and I want you to have a great reInvent. Please, as a final ask, complete the session survey. Your feedback is really welcome, and we'll really use that to drive our next initiatives. Thank you very much. See ya.